Hello everyone. In this session, we will learn what Python lists are and why they are so powerful. Let's begin with creating list. The most common and intuitive way to create a list in Python is by using square brackets. Inside the brackets, we place values separately by commas. Here, we create a list of numbers with values 10, 20, 30, and 40 using square brackets. Then we create another list that contains different data types, numbers, text, decimal values, and boolean. Python allows this flexibility, which is one of the reasons lists are so widely used. When we print this list, Python displays all the elements in the same order in which they are added. The second way to create a list is by using the list constructor. This method becomes useful when we want to convert another data structure into a list. For example, when we pass a string data stored in text into the list function, Python breaks the string into individual characters and stores each character as a separate element in the list. This technique is especially helpful in text processing and data transformation tasks. The third method uses the multiplier operator. Here, we create a list containing a single zero and multiply it by 7. Python replicates the element 7 times, giving us a list with 7 zeros. This approach is commonly used when initializing list with default values. Now, let's move on to accessing data from a list. Python uses indexing, and indexing always starts from 0. So, when we access index 1, Python returns the second element, not the first. Fruits of 1 returns banana. Python also supports negative indexing. An index of -1 always refers to the last element in the list, making it very convenient when working backward. Fruits of -1 returns kiwi. In addition to accessing single elements, we can extract multiple values using slicing. When we specify a start index and an end index, Python returns elements starting from the first index and stopping just before the second. Fruits of 2:4 gives second index cherry and third index orange. If we leave the start or end empty, Python automatically fills in the gap for us. Let's now grow the list by adding new elements. The simplest method is append. Append adds exactly one item to the end of the list. Nothing else changes. The list simply becomes longer. Next is insert. Insert allows us to place an element at a specific position. Python shifts the existing elements to make room for the new one. Inserting 1, orange places orange in index 1 position, moving the existing elements. Then we have extend. Extend is used when we want to add multiple elements at once. Instead of adding a list as a single item, extend adds each element individually to the original list. This distinction is very important and often misunderstood by beginners. Now, let's see how we can modify existing elements. Because lists are mutable, we can directly replace values using their index positions. When we assign a new value to a specific index, Python updates the list instantly. Just by assigning blackcurrant in first index position, the list gets modified. We can also modify a range of elements using slicing. When we replace a slice, Python removes the old elements and inserts the new ones. An important thing to notice here is that the number of replacement elements does not need to match the number of elements being replaced. This can either expand or shrink the list. Next, we focus on removing elements from a list, also known as pruning. The remove method deletes the first occurrence of a specific value. It searches by value, not by position. The pop method removes an element based on its index and returns that value. It is useful when we want to remove an item and still use it later in our program. If no index is provided, pop removes the last element by default. The del keyword allows us to delete elements or even slices of a list. Finally, the clear method removes all elements at once, leaving behind an empty list that can still be reused. Let's now look at processing list using loops. The most Pythonic approach is to loop directly over the elements of the list. Python automatically picks one element at a time and assigns it to a variable. This method is clean, readable, and preferred in most situations. Sometimes, however, we also need the index position. In such cases, we loop using range and length together, accessing elements by their index. Both approaches produce the same result, but each has its own use case. Now we arrive at one of the Python's most elegant feature, list comprehension. A list comprehension allows us to create a new list in a single readable line of code. Here, we filter fruits that contain the letter A. Instead of writing multiple lines with loops and conditions, we express the logic clearly in one statement. For fruit in fruits, this part tells Python to go through the list fruits. Pick one element at a time. Temporarily store it in the variable fruit. A in fruit. This is a membership test. Python checks whether the character A appears anywhere inside the string stored in fruit. The result is a Boolean value, true or false, and the word fruit at the beginning. This is the output expression. If the condition is satisfied, Python adds the value of fruit to the new list. List comprehensions can also perform transformations. In this example, we generate square numbers from 1 to 5 using a concise expression. It takes from 1 to 5 and makes square for each value. This style of coding is not only shorter but also easier to read once you get used to it. Let's now organize our data using sorting. The sort method rearranges elements in ascending order by default. It modifies the original list directly. If we want the reverse order, we simply set the reverse parameter to true. Sorting becomes extremely useful when working with numerical data, rankings, or ordered records. Now let's explore nested list. A nested list is a list that contains other lists as elements. This structure is often used to represent tables, matrices, or grids. To access a value inside a nested list, we use two index positions. The first index selects the row and the second selects the column. Matrix 1, 2 gives 6. This concept becomes very important later in data science and machine learning. Now, let's discuss on copying lists correctly. When we assign one list to another variable, Python does not create a new list. Instead, both variables point to the same object in memory. As a result, changes made to one list appear in the other. To avoid this, Python provides proper ways to copy list. We can use the copy method, the list constructor, or slicing. All three approaches create independent copies, preventing unintended side effects. Let's now look at joining list. Using the plus operator creates a brand new list by combining elements from both lists. The original list remain unchanged. Using extend, on the other hand, modifies the existing list by adding elements from another list. Choosing between these two methods depends on whether you want a new list or want to update an existing one. Finally, let's understand what happens behind the scenes. A Python list does not store actual values. Instead, it stores references to objects in memory. This design allows lists to hold mixed data types efficiently. It also explains why modifying a mutable object inside a list affects all references pointing to that object. That brings us to the end of this hands-on session. Python lists are flexible, powerful, and foundational. Mastering them early will make your journey into data analytics, machine learning, and AI far smoother. Thank you for learning with me.